Welcome. In Python, sometimes you have data in one format, like a string, but you need it in another, like an integer, to perform math. This process is called typecasting. It is a fundamental skill that allows your programs to handle data flexibly and prevents errors during calculation. Think of your variables as boxes with different shapes. An integer is like a small block, while a string is like a long piece of paper. You can't just shove a long paper into a small block-shaped box. Typecasting is the act of resizing that data so it fits perfectly into the destination container. Python handles some conversions for you, which we call implicit conversion. For example, adding an integer to a float automatically creates a float. However, explicit conversion is when you manually change a type using functions. This gives you full control and ensures your program behaves exactly as you intend. To convert values into numbers, we use the int and float functions. Notice here how we take a string 25 and turn it into a number. By casting the integer 10 into a float, Python treats the result as a decimal, demonstrating how casting affects the final data structure. You cannot combine a string with an integer directly. If you try, Python will throw an error. To fix this, we use str to turn our number into text. This allows us to concatenate it with the score label, making it perfect for printing or displaying to the user. Sometimes you need to combine numbers with text. Because Python won't let you add a number directly to a string, we use the str function. This converts values into their string representation, which is perfect for printing results to the user console or building log messages. Here is that in action. If we try to add the integer 95 to our string score, Python throws a type error. By wrapping our variable in str, we safely turn it into 95, allowing the two strings to concatenate perfectly into score 95. Python uses truthiness to decide if a value is true or false. Using bool, integers like 0 or empty strings become false, while any other value is true. This is incredibly useful for checking if a user has actually entered text into an input field. You can also convert data structures. If you have a tuple of items but need to modify one, pass it into list to make it mutable. Conversely, use tuple to lock a list, ensuring it cannot be changed later in your program's execution. The most common mistake for beginners is attempting to concatenate strings with integers or floats without casting. Python is strongly typed, meaning it won't guess your intentions. It demands that you manually convert the numbers to strings before they can join the text. Here is a crucial tip. Python is very strict about what it can convert. If you try to cast a string like ABC into an integer using int, Python will throw a value error and crash your program. Always ensure your string contains valid numeric characters before attempting a conversion. To build robust software, you should handle potential errors gracefully. By wrapping your conversion logic in a try-except block, you can intercept those value error crashes and display a friendly message to the user instead of letting the entire program fail. Time for a quick check. What happens when you try to cast the string 10.5 into an integer? Take a moment to think. Remember, int expects a whole number string, not a float formatted string. The correct answer is C. It raises a value error. To convert 10.5, you'd use float first. To wrap things up, always use typecasting to ensure your variables share the correct formats before performing operations. Remember to cast user inputs before doing math, and keep in mind that converting floats to integers will truncate the decimal, causing potential data loss. You've mastered type conversion. Let's wrap up with 3 key takeaways for your toolkit. First, always remember that user input arrives as a string, so cast it immediately before processing. Second, ensure your variable types match before performing math to avoid errors. Finally, be mindful that converting floats to integers will truncate decimal values, causing data loss. To drive this home, look at this precision check. When we cast the float 9.99 into an integer, Python simply chops off everything after the decimal point. Notice the output is 9, not 10. Understanding that this is a truncation, not rounding, is vital when you are dealing with financial or scientific calculations.